Okay, so what's an isosceles triangle? Okay. Okay, so the two sides that are the same, those are called legs. So the two legs of an isosceles triangle are congruent. And then the side that is not the same is called the base. Okay. This angle up here is called the vertex angle. There's something really special about isosceles triangles besides the fact that they have two congruent sides. Do you know what that is? My dad told me that. Okay, these guys right here are called base angles, and they are going to be congruent. Okay, how do we know where the base angles are? The base angles are always going to be across from the legs. So the two angles that are up across from the legs are going to be congruent angles. Okay, so here's the deal. If we have a triangle with two congruent sides, then we know that it's isosceles, and then we can, with this theorem, imply that the base angles are congruent. So if the two sides are congruent, then we know the two angles are congruent. Okay, we can also go the other way. If we have two angles that are congruent, their opposite sides are going to be congruent. Okay, are you okay with that?
I'll go.
Okay. If isosceles, then base angles are congruent. If base angles are congruent, then isosceles. We have those two opposite sides. Okay. What?
That's basically.
No, or no go to proofs. There was proofs in 5.3.
We're coming back. We're coming back. Can you please draw this triangle?
What's the second one?
Where it says notes. Just roll with it. Can an isosceles triangle be obtuse? Time out. Can it?
Yes.
Yes. Yes.
No. Yes.
Yes. Oh, yeah, okay,
No,
yeah.
it may not.
Yes.
Yes, it can.
That's exactly what you did, Sam. Yeah, that's what you did. We just established that. We just did that. We just did that.
Can it be a right triangle?
No. Oh, wait.
45, 90. That's a special triangle. We're gonna talk a lot about that triangle here in a few months. Don't blindly agree with Brayden if you don't know what.
We're not doing it didn't look like when I saw it was trying. It's because we had it oriented. Braden told me it couldn't be. Right.
I trust Brittany with everything. So,
Okay.
highlights are so good.
Nora, how do we determine the value of X? Okay, we have an isosceles triangle where our sides are the same, right? So across from our congruent sides, our base angles should be congruent. So we can say, all right, 3x plus 22 equals 2x plus 40. What? Okay. All right, what's X? How the heck do I figure out why?
You just.
You
add it on the bottom and then it goes up to 180.
180.
Yeah.
Yeah.
Yeah, but both of them are 76.
Okay, how did Clark get that these are 76? So if we plug 18 in, 2 times 18 plus 40 is 76?
Yes.
And 3 times 18 plus 22 is 76?
Yes.
Yeah.
We technically don't have to do the math.
152, 28. Why
Okay.
is 28?
28?
Yeah.
Do you agree with Ben? Or are we just blindly agreeing with him and not checking him?
I don't do
I don't do that.
Did you just say you don't do that?
that. I agree with that.
Okay. All right, at the top of page 141. Some corollaries here. They're like an extension off of our theorem. If the triangle is equilateral, then it's equiangular. And if the triangle is equiangular, then it's equilateral. So we know that if we have an equilateral triangle, all of the angles are
Equal. Congruent.
which would be, and if they're all congruent, what are they?
Equal.
Wait a second.
Wait, linear.
What's the number?
365. 300.
60.
360.
What? What do three angles of a triangle add up to be, Sam?
Yeah.
Wait a second. We use the transitive property, if the triangle is equilateral, then it's equiangular. If a triangle is equilateral, then it's equilateral. What? No.
What is he saying?
No, but it can't. No, I was trying to use the transitive property.
There is no transitive property right now. This, however, is biconditional, where it's true forwards and backwards, so it's an if and only if. All right, let's come down to this guy right here. Okay, so if NJ is congruent to NM,
Equals NJ, basically.
Yeah.
NM equals But they're telling us that that's what's true. So, but if we have two sides of a triangle congruent, then we know the base angles are congruent. So what would be our base angles? J and M. So angle J is congruent to angle M. We know that these two would be congruent because these sides are congruent. Okay. Now, in our next one, LM is congruent to LN.
J equal is congruent to equal N.
Okay,
Wait, no. What? If angle J and angle is congruent to angle M and angle M is congruent to angle N, then isn't angle J congruent to
so
angle N?
right now what we're gonna do is we're just one statement at a time. If these two are congruent, then we're gonna name our base angles, which would be these right here. Now I cannot call that angle N because there's multiple angles with the vertex of N. So we're gonna call it LNM, which would mean we can call the other one
JL.
this guy.
M.
We can call it M, that would be fine. Or LMN.
Yeah.
All right. New set of information. NKM this angle right here, right? Is congruent to NMK. That's this guy right here, right? All right, so what I'm gonna do to maybe help us out is I'm going to highlight the triangle that these angles are in. Okay, so what does this imply? We have two angles that are congruent in a triangle. So which two sides are congruent? Okay, so across from K is side MN. And across from angle M is side
KN.
good. Okay. And then in number 4, LJN, so that's this guy right here, is congruent to LNJ. Okay, so I think it would be helpful if I highlight this triangle for us to see. Like that. Okay, this one, I know there's a lot going on. It's a lot harder to see. What are the two sides that are congruent? LN and either an LJ. K is not an endpoint. We can't use K.
How do you know like what angle to do? Because it's like JJ, and how do you know that it's like J?
Okay, so what we're gonna do is we're going to follow the letters, okay? So if I'm talking about, look up here, L, J, N. If I literally follow L to J to N, that's the angle I map out. This guy. Do you see what I'm saying there?
So would it just be like the one in the middle?
So it's the one that has a vertex of J with sides LJ and sides JN. And then if we have L and J, this one right here, I'll do in blue. Here's L, and then I go to N, and then I go to J. So its vertex is at N, and then there are the sides. So it's from side to side. Okay, go ahead and turn the page. I'm gonna give you 60 seconds to do number 5 and number 6. I believe in you. I wanted you to do 5 and 6 right now.
Five and seven.
Just 5 and 6. Woof. Presley, in number 5, what is X? How do you know that? All sides are, and how does Presley know that all sides are equal?
If it's equilateral, it's equal angular.
Okay, if it's equal angular, we know it's equilateral. Awesome. In number 6, Sam, what is X? Okay, what's true about this triangle? It's equilateral, which means it's also equiangular, which means each angle is 60 degrees. So X is 30. Do a lot of work. Okay, I will give you 2 minutes to do 7 and 8. I believe in you.
Y minus 35.
Which one's easier?
Number 8.
No.
Number 8. Number 7 is longer, but
Seven. Oh.
how do you do 7? I can't do 7.
Yeah.
All right, let's talk about number 7. Okay, don't freak out too much here. What is the measure of this angle right here?
60.
So what's the measure of this angle?
30.
And what's the measure of this angle? Well, not yet.
Why?
Ah, so 2y plus 30 equals 180.
Oh.
So y is 75.
Wow.
And if y is 75, what is this?
50.
50, which means what is this?
50.
Wow.
Which means what is this?
50.
And if these two are congruent,
X equals 50.
then these two sides are congruent and x equals 50.
Oh my gosh.
You just had to break it down.
Break it down. Wait, what? Would love to.
Oh, okay, okay.
This
No.
triangle.
Two triangles that share a side. What's true about this triangle right here?
Lateral.
It is equilateral.
60.
So yeah, each of those angles are 60 degrees. Does that even matter? It does? No. Can we solve for y first? No, we must use x. So what do we know about this top triangle?
It's isosceles.
Okay, so this guy is x degrees right here. So 2x plus 40 equals 180, which means x is what?
60.
Yeah.
70.
Why are we this?
That's hurtful.
What's 140? 180 minus 40? Okay.
Yep.
So that means this is really 70 minus y. So now we know that 2y plus 10 is 70 minus y. Do you agree? So 3y equals 60, aka y equals a 20.
That makes sense.
So,
You quit? You didn't understand what?
no, I understand. It just happens. No, because look, if x is 70, you're just making them equal to each other.
What do you mean different form?
Cause you know that x minus y is equal to 2y plus 10. It is written different.
I didn't
But
think
now,
about the X.
but now it's 70 minus y, and they're written differently, but they're the same.
I didn't know that you could do X.
Open up your packet. I'm assuming to page 3. And by 3, I mean 2. Page 2 and page 3 is your homework.
What the fuck?
Page 2 and page 3.
Oh, wait, that's.